Hi everyone, this is the last example I'm going to do for the differentiating e to the x. Now, this question is actually taken from the Cambridge Senior Mathematics Australian Curriculum BC Mathematical Methods Unit 3 and 4 book. But differentiate e to the following, then evaluate the derivative at x equals 2 given f of 2 is equal to 0, f dash 2 is equal to 4, and f dash e squared is equal to 5. Now, to do a question like this, it's much more general than some of the other ones that we have worked with, but first things first, I'm going to differentiate this, so I can just say that dy dx is equal to, and remember that with the exponential function we take the derivative of the power and we put it at the front, so it's going to be f dash x e to the power of fx. So at x equals 2, we're going to have dy dx equals f dash 2 e to the f of 2. And we have this information in our question. So f dash 2 was 4. And f of 2 was 0. So 4e to the 0 just means 4 times 1, which is 4. In the second part of the question here, we need to differentiate f of e to the x. Now, that last question that we did was actually a chain rule problem as well, even though I didn't do it that way, but we're going to use the chain rule to do this one here, because we can see we have the e to the x function inside the f of whatever is function. So the inner function is e to the x. I'm going to say let u equal e to the x. So that means that du dx is also equal to e to the x. That means that y equals f of u, and when we differentiate that, dy du will be f dash u. So I can then say that dy dx is equal to dy du by du dx. And subbing in what we know, dy du was f dash u multiplied by du dx, which was e to the x. And lastly, subbing u back in, we get f dash e to the x multiplied by e to the x. So we're nearly done, but when x equals 2, we get dy dx equals f dash e to the power of 2 multiplied by e to the power of 2. And again, going back to the question, we know that f dash e to the power of 2 is equal to 5. So that's just equal to 5e to the power of 2, or 5e squared. And that's the answer. Anyway, I think that's all I need to do there, so we'll leave it there and yeah, continue on later. I'll see you later.